Let's look at what we want for our desired behavior here. Now I changed my icon from the brick wall with fire coming out of it to this round icon with the skip forward to the next song icon in the middle. This is the icon for Cisco firewalls. In my demonstrations, I'm going to be using a Cisco firewall. For me personally, I really like this icon because it's easy to draw both on a whiteboard and on a sketch on paper, and we'll just make use of it here in the PowerPoint presentations as well. On the left, I have an inside PC. This is going to be in our trusted zone. On the right, I have our outside web server. This is going to be in our untrusted zone. So here's the desired behavior that we're looking for. If I'm a user on that inside PC and I want to browse to the outside web server, I want to send a TCP SYN message to that server. I want the server to be able to reply to me, and I want to be able to send the TCP ACK so we can complete the three-way handshake and then transfer any information we want. That's what I'm looking for. I need that firewall to allow me to send out a SYN message, receive a SYN ACK back, and then be able to send the TCP ACK out again, and then be able to transfer data over that connection. What I don't want to have happen is to have my outside web server send a TCP SYN message into the firewall. I want that message to disappear. I want the firewall to block that message. Because what I don't want is I do not want outside devices building TCP sessions from the outside to the inside unless I explicitly allow them. So how we're going to accomplish this is with a TCP State Table. This is where the concept of a stateful firewall comes into play. The TCP State Table, what we're going to do here is as messages traverse the firewall, we're actually going to record the TCP state of the session that's being created. And we're going to do that by recording the source IP and port, destination IP and port, and then the TCP state that it's currently in. In this case, if I want to browse to the outside web server, my TCP SYN message takes a very brief pit stop at the firewall. It records the source IP, the destination IP and port, and the current state. The current state is that the SYN message has been sent. Once we record that state, we send that to the outside web server. The outside web server can then respond with the SYN ACK. When that SYN ACK comes in, the untrusted zone by default is going to block all traffic originating from the outside. However, we want to get this TCP SYN ACK back into our inside network. So what we're going to do here is we're going to take that SYN ACK coming back from our outside web server, and we're going to compare it to the TCP state table and see if we're expecting this message to come back. Now, of course, the source IP and port and destination IP and port are going to be flip-flopped in my chart for the return traffic, but it's all the same basic information. Since the last TCP state recorded in the table was SYN sent, what we're going to be looking for and allowing is a SYN ACK message back from 172.25.10.100 on port 80 going to my inside PC's workstations. Since that's the case, we will then change the state of our TCP state in the table, forward that message on to the inside PC, and then allow the inside PC then to send the TCP ACK. When the ACK flows through the firewall, we once again change our state from SYN ACK to established, and we forward that message on. Now, since the state is established, any conversation happening between the inside PC and the outside web server on the IP addresses and port numbers listed in our table, all that traffic will be allowed. If the outside web server attempts to send in a TCP SYN message from the untrusted zone into the firewall, well, this is going to be denied. There is no rule that says allow a TCP SYN message in here. As a matter of fact, we're explicitly denying all TCP SYN messages. The only TCP SYN messages that can flow through the firewall are the ones that flow from the trusted zone to the untrusted zone, and not the other way around. So this message is going to get denied and thrown away. That's how we're using our TCP state table to allow our inside user to browse to the internet and get responses, but prevent folks out on the internet in our untrusted zone from browsing into our network and accessing internal resources. We're using this state table to permit or deny traffic based on where the traffic was originated.